Hello, sir. Myself, Prakash Bharti, and I am a student of MSc PhD double degree. So today my presentation is on superconductor. What are superconductors? Uh, we can read about the superconductor. So firstly, question is arising: what are superconductors? A superconductor is a material that achieves superconductivity, which is a state of matter that has no electrical resistance and does not allow magnetic fields to penetrate. An electric current in a superconductor can persist indefinitely. Superconductivity can only typically be achieved at very cold temperatures. Superconductor is the ability of certain material to conduct electric current with practically zero resistance. This capacity produces interesting and potentially useful effect. For a material to behave as a superconductor, low temperatures are required. So this is the definition of superconductor. Now we are going to what are the properties of superconductor. So first property is a critical temperature. The critical temperature for superconductor conductors is the temperature at which the electrical resistivity of metals falls to zero. Most material show superconducting phase transition at low temperature. The highest critical temperature was about 23 Kelvin until 1986, and after that year and year the critical temperature increases. And the next property of superconductor is zero electric resistance. Superconductivity is the phenomena of zero electrical resistance that occur in certain materials at a very low temperature. Substance that have become superconductivity are known as superconductors, and when coiled they are known as superconducting magnets. And the other third property of the superconductor is explosion of magnetic field. So uh, the missionary effect, the explosion of a magnetic field from the interior of a material that is in the process of becoming a superconductor, that is losing its resistance to the flow of electrical currents when cooled below a certain temperature called the transition temperature, usually close to absolute zero. Now, the next property of superconductor is critical magnetic field. For a given temperature, the critical field referred to the maximum magnetic field strength below which a material remains superconductivity. Superconductivity is characterized both by perfect conductivity, it means zero resistance, and by the complete exclusion of magnetic field, the Meissner effect. Now, these are the properties of superconductor. And next here I present the methodology. So in methodology for the present study, we selected H2S because it is relatively easy to handle and is predicted to transform a metal and a superconductor at a low pressure. P is equal to 100 gigapascal with a high critical temperature is equal to 80 Kelvin experimentally. H2S is known as a typical molecular compound with a rich phase diagram at about 96 gigapascal. Hydrogen sulfide transformed to a metal. The transformation is complicated by the practical dissociation of H2S and the appearance of elemental sulfur. P is greater than 27 gigapascal at room temperature. And at high pressure at low temperature, therefore, the metallization of hydrogen sulfide can be explained by elemental sulfur, which is known to become metallic above 95 gigapascal. No experimental studies of hydrogen sulfide are known above 100 gigapascal. So in methodology, basically, this is the working or methodology of making the superconductors. Now next is result. What are the result obtaining from that made of superconductor? So firstly, during the cooling of metal at pressure of about 100 gigapascal, the resistance abruptly drop by 3 to 4 order of magnitude, indicating a transition to the superconductor states. At the next increase of pressure at low temperature of T less than 100 Kelvin. This graph shows the variation of temperature and the temperature and resistance. So now the next Tc steadily increase with pressure. However, at pressure of 160 gigapascal, Tc increased sharply. As higher temperatures of 150 or 250 Kelvin were involved in this pressure range, we supposed that the increase of Tc and the decrease of sample resistance during warming could indicate a possible kinetic controlled phase transformation. And this graph explain about all things in the result. This allowed us to obtain stable result to compare different isotopes to obtain the dependence of Tc on pressure and magnetic field, and to prove the existence of superconductivity in our sample as follows. So these pictures show in in different pressure superconductors show different property by this picture. Main panel temperatures dependence of the resistance are of sulfur hydride at different pressures. The pressure value are indicated near the corresponding plots. At first, the sample was then cooled down to 4K after warming to 100 Kelvin. Pressure was further increased. Plot at pressure less than 135 gigapascal have been scaled reduced as follows: 105 gigapascal by 10 times, 115 gigapascal and 122 gigapascal by 5 times, and the 129 gigapascal by 2 times for easier comparison with the higher pressure steps. The resistance was measured with a current of 10 microampere. Now these are the result we obtained from the made of superconductor. So superconductivity. Now next is about the conclusion. What are conclusion are made from the making of superconductor? So the highest Tc of 203 Kelvin that we report here has been achieved most probably in S3s having the structure. It is a good metal. Interestingly, there is also strong covalent bonding between H and S atoms in this compound. So basically, in year and year after 1986 and year, the critical temperature is increased by year. So the highest critical temperature is 203 Kelvin. It is a good metal. Strongly, that is interestingly, there is also a strong covalent bond between H and S atoms in the compound. In this compound, this is in agreement with the general assumption together with high frequency modes in the phonon spectrum. This particular combination of bonding type and phonon spectrum would probably provide a good uh, criterion when searching for applications. Now the references. What are the references of this presentation? Actually, first is research paper of conventional superconductivity at 203 Kelvin at high pressure, the sulfur hydride. Uh, I taking help from the research paper, and next is Google. So this is my presentation, or is all about on superconductors. And thank you so much, sir. This is the end of my presentation.